Dear viewers, I'll be treating with us transportation problem. A transportation problem is a form of linear programming model which ensures that resources are dispatched from one location to another at a minimum cost. The sole objective of transportation problem is to minimize cost to its barest minimum. In a nutshell, transportation problem entails transferring goods from one destination to another so as to minimize cost. Now, the conditions that must be satisfied before solving a transportation problem is that the first one is your m plus n minus 1 must give you the number of allocated cells. The meaning is the number of rows and the number of column. If you add the two together, minus 1 must give you the number of allocated cells. I will explain that as the lecture goes on. But if not, there is degeneracy problem which must be solved. This degeneracy problem, I will solve it in subsequent videos, but not in this video. Now, the second condition is the supply must be equal to your demand. Supply must be equal to your demand. That's what we call balanced problem. Now, whenever you are solving transportation problem, your supply must be equal to your demand. But if supply is not equal to demand, definitely we have unbalanced transportation problem. Here, you have to create either a dummy row or a dummy column. This will not be considered in this lecture. It will be considered in subsequent lecture. Now, there are two phases to be encountered when solving transportation problem. The first phase, the two phases to be encountered when solving transportation problem is, the first one is how you are going to determine the initial feasible region. That is, how are you going to allocate the cells. Now, under this, we have three methods of allocating. You can only pick one out of the three. The first one is the northwest corner method. The second one is the least cost method or the minimum cost method. It's still the same thing. And then the third one is the Vogel approximation method. So I will take this in turn, one after the other. So for the purpose of this lecture, the northwest corner method will be treated in this lecture. So the second phase is how to determine the level of optimality using the MODI method, that is modified distribution method. Now, there are some steps we have to follow whenever we are solving a transportation problem. The first step is you check whether supply is equals to demand. That's the first thing. You have to check whether supply is equals to demand. And I've already said that earlier. I said if supply is not equal to demand, you either create a dummy row or a dummy column. So the B aspect, you determine the initial feasible region using either the northwest corner, I've explained that, the least cost method, or the Vogel approximation, like this, which I've explained earlier. These three, either you use this or this. Now, the third one is after you might have allocate using the northwest or least cost or Vogel, you check whether the number of rows plus the number of column is equal to the number of allocated cells. You are going to check. If not, there is degeneracy problem which must be taken care of. This will not be considered in the course of this lecture if there is degeneracy problem. So the fourth is you determine the optimality as follows. The first is you compute the shadow cost of the allocated cells. Then two, you check the level of optimality, whether there are positive values. If there are no positive values, the optimal solution has been reached. If there are positive values, the optimal solution has not been reached. Hence, there is need to create a closed loop. So I shall proceed by solving an illustration which will enable us to better understand the transportation problem. Now, illustration. This is a good example of a transportation problem question. These are cells. These are row 1, row 2, row 3, column 1, column, these are column 4, 3, column 2, column 1, stuff like that. So here you will see these are the cost of transportation in each cell. The cost of transportation in each cell. Now look at this. The implication of this is that depot 1 can transfer goods to shop 1 at 13 naira. Depot 1 can also transfer goods to shop 2 at 11 naira. Depot 1 can transfer goods to shop 3 at 15 naira. This to shop 4 at 20 naira. The same thing goes to depot 2. Depot 2 can transfer to shop 1 at 17 naira, to shop 2 at 14, stuff like that, Now, having said that, you will see that this is your demand. These are the people that are demanding for the goods. For what? For the goods. And these are the people that want to supply it. This depot, they want to supply to these shops. Hence, this is a supply, this is a demand, and this is supply. You can see the question says solve the transportation problem below using the northwest corner method of allocation. Now, we have our demand and we have our supply. Now, and remember, I gave you a step and I gave you some conditions that must be fulfilled. The one of the step is that your supply must be equals to your demand. So let's check for that, whether our supply is equals to demand. Now, this is my supply. 2 plus 6 plus 7. That's what? That should be 15. Here, 3 plus 3, that's 6, plus 4, 10, plus 5, that's 15. You can see that my demand is equals to supply. You can see my demand is equals to supply. So the first step has been taken care of. That's the step 1. Check whether supply or demand is equal. So the step 1 has been taken care of. Now the step 2, you determine the initial feasible region. Now I said using either any of these three. So based on this question, we were told to use the northwest corner method of allocation. So this is my demand and this is my supply. So all the cost of transportation, they are here. Look at them here. I've put them here. Can you see them? So this is the supply and this is demand. Remember, there are 15. My supply is equals to my demand. You can see my supply is demand and demand, they are equal. So I will name this row 1, row 2, here to be row 2, and here to be row 3. Here I will name this column 1, column 2, column 3, column 4. Now listen and pay attention to this. Here I'm using northwest. Northwest corner. Here. Now, under the northwest corner, you start from the left hand side. You start from this place, this corner here. You pick. Now, you pick here. You see that under here, you see that we have 3 and we have 2. In order for you to understand this better, you pick the lower between these two. between these two figures, you pick it, you write your 2. The implication of this is that depot 1 has supplied 2 goods to shop 1. You can see, since depot 1 has supplied 2 goods to shop 1, you see that depot 1 did not have any goods again after he might have supplied it, but shop 1 still need 1. Can you see? Definitely depot 1 cannot distribute any goods to any of this again. This one may cancel. Have you seen it now? You cancel it. Now you are through with this here. Can you see now? So it remain this. Can you see? It remain this. Now you go back here again. Then you will see that depot 2, shop 1 still need 1, but depot 2 has 6. And I said you always use the lowest between these two. You can see between 1 and 6, 1 is the lowest. You put your 1. Definitely this one become 0 and this one become 5. Are you getting it now? Since this one is 0, this one did not need anything again. You cancel this side. Definitely we are through with this aspect. It remains this. Are you getting it now? This. Now the next one is you pick this. This one we have 3 and we have 5. So the lowest between 3 and 5, you pick 3. You pick 3. 3 minus 3 is 0. 3 minus 5 is 2. Are you getting it now? Since this one is 0, definitely this one has cancelled. There's nothing to give this person again. It now remain this. Are you getting it now? It now remain this. So here 4 and we have 2. 4 and 2. Remember we are dealing with this 4 and 2. You pick 2 because 2 is the lowest. Definitely there is nothing again. This one will remain 0. This one remain 2. Since this one is remain 0, then this one will be has been cancelled. It now remain this. Now between this and this, which one is the smallest? 2. You write your 2. Then this one remain 5. Then after the 5, this one has cancelled. Then it now remains this. You can see 5, the last figure 5. This one remains 0 and this one remains 0. Now you've already allocated your cells. You've already allocated them. So you see, we satisfy the step 2. Determine the initial feasible region using the northwest corner. We have already done that using the northwest corner method. The step 3, you confirm that m plus n minus 1 is equals to number of allocated cells. Remember I said m is number of row. How many rows do we have? 1, 2, 3. Confirm that m plus n minus 1 is equals to number of allocated cells. Your m is row. The number of row is 3 and the number of column 1, 2, 3, 4. You have 4 minus 1 is equals to what? 6. Now let's count maybe 6. 1, 2, 3, 4, 5, 6. That is the cells you allocated. 1, 2, 3, 4, 5, 6. You can see that the m plus n minus 1 is equals to 6. If it is not equal to 6, if it is less than 6, definitely there is degeneracy problem, which will be treated in subsequent videos, not in this video. The next one I'm going to upload will be where there's degeneracy problem. Now the third one is, let's determine the optimality, the level of optimality. So in order to determine that, we are going to compute the shadow cost of allocated cells. Shadow cost of allocated cells. Now you will see that the shadow cost of allocated cells, this is what you will use to determine it. The row plus column is equals to the actual cost of allocated cells. Now here you start from, remember I said allocated cells. These are your allocated cells. This one is not there because they are not allocated. Here this they are allocated cells. Can you see? So the first one is, you see that row 1 column 1, row 1 column 1. So I said row 1 plus your column 1 must give you the actual cost of allocated cells. The actual cost is these small figures that are here, the cost of transportation. Look at it. This row 1 column 1 is 13, so you write your 13 there. Now whenever you are doing this, you always assume that row 1 is 0. Let row 1 is equals to 0. Since you know that your row 1 is 0, you just say 0 plus column 1 is equals to 13. Hence column 1 is equals to 13 minus 0. Then column 1 is equals to 13. Column 1 is 13. The next is row 2 column 1. And you see row 2 column 1. Row 2 plus column 1 is equals to, you see, 17. Have you seen it? 17. So my row 2 is, let me check, maybe I have row 2. I do not know my row 2. My row 2 plus, but I know my column 1 to be 13. Can you see? My column 1 is 13 from what I've solved earlier. So you write your 13 plus 13 is equals to 17. Hence your row 2 is equals to 17 minus 13. Row 2 is equals to 4. The next one, row 2 column 2. You can see row 2 column 2. That's row 2 plus column 2 is equals to 14. Row 2 plus column 2 is equals to 14. You can see 14. So my row 2, as I've solved here, my row 2 is 4 plus column 2. I don't know my column 2 to be 14. Then you say column 2 is equals to 14 minus 4. Then column 2 is equals to 10. Next one, I have row 2 column 3. Are you seeing it? Row 2 column 3 is equals to 12. So row 2 plus column 3 is equals to 12. My row 2, as I've solved here, is 4 plus column 3 is equals to 12. So you say column 3 is equals to 12 minus 4. Column 3 is equals to 8. Next one, row 3 column 3. Row 3 column 3. So row 3 plus column 3 is equals to 14. Now my row 3, I don't know, but I know my column 3 to be 8. So row 3, I have a row 3 equals to 14 minus 8. Row 3 is equals to 6. Now the next one, we have a row 3 column 4. Row 3 plus column 4 is equals to 12. So row 3 to be 6 plus column 4 is equals to 12. Column 4 is equals to 12 minus 6. Column 4 is equals to 6. Hence we have column row 1 to be 0. Remember, row 1 is always 0, comma, column 1 is equals to 13, row 2 is equals to 4, column 2 is equals to 10, column 3 is equals to 8, row 3 is equals to 6, column 4 is equals to 6. Now, we satisfied this. Compute the shadow cost of allocated cells. Now, the next thing is to check the level of optimality. Now, in order to do that, row plus column minus actual cost of unallocated cells. So whenever you are doing this, you have to focus on your unallocated cells. Remember this, we use our allocated cells to determine the shadow cost. Are you getting it now? So here we are going to use, in this next step, we are going to use the unallocated cells to determine the level of optimality. Now, in order to do that, I will look at my unallocated cells. Look at my unallocated cells. Row 1. I have row 1. Then we have row 1, column 2. And you see, remember we are using this row 1 plus row plus column. So we also have row 1, column 3, row 1, column 4. That is the unallocated cells. Row 1, column 3, row 1, column 4. We also have row 2, column 4. Row 2, column 4. We also have row 3, column 1 and row 3, column 2. Row 3, column 1 and row 3, column 2. Now, row 1, remember your row 1 is always 0. Row 1 is 0 plus column 2. Column 2 is 10 minus this row 1, column 2. Look at the actual cost of unallocated cells is 11 minus 11. This one will give us minus 1. Here, the next is the second one. Row 1, column 3. Row 1 is 0 and my column 3 is 8 minus 15. Row 1, column 3, 15. We have minus 7. Go on again, we have row 1, column 4. Row 1, which is 0, plus column 4. Column 4 is 6 here. Minus row 1, column 4, we have 20. Pick your 20. Will be equals to minus 14. Row 2, column 4. I have my row 2 to be 4. Column 4 to be 6. Minus row 2, column 4 to be 13. Are you getting it? 13. Hence, we have minus so row 3, column 1, I have my row 3 to be 6 plus my column 1 is 13 minus, so row 3, column 1 is 18. So that will be 1, that is 19 minus 1. So row 3 again, we have 6 plus column 2 is 10 minus row 3, column 2, we have 18. 18. That will be 16 minus 18. We have a minus 2. Now, remember that I told you earlier that to check the level of optimality, you have to determine whether there are positive values. And if there are no positive values, the optimal to check whether they are positive, and if there are no positive values, the optimal solution has been reached. But if there are positive values, the optimal solution has not been reached. Hence, there is need to create a closed loop. Now, you will see here that we have a positive value. We have 1, a positive value. So definitely we are not through with our solving. So we still have to create a closed loop. Assuming we have two positive values, like assuming we have 1 and we have 3, you are going to pick the highest positive value to create the loop. Definitely the positive value here based on my result is row 3 column 1. Are you getting it now? So let me create a closed loop for row 3 column 1. Now in order to create a loop, you have to redraw what you've already done here. You have to redraw it. Now remember how we allocated this cell. Now whenever you are creating a loop, you start from these positive figures. Remember, you want to loop this row 3 column 1. Definitely we are starting from here, row 3 column 1. Now, and whenever you are looping, please take note that you must loop to cells that are allocated. Never make the mistake of looping to an unallocated cells. Now I will start my loop from here. I can go like this, or I can go like this. Do not loop diagonally. You can loop vertically or horizontally. Are you getting it now? So I can take my loop from here, positive. I can take my loop from here to here. I cannot stop here because this is an unallocated cells. You can see I did not put anything here. These are unallocated cells. So you have to do your loop to an allocated cells. I know some people will be thinking that why didn't I put it here? The reason why I did not put it here, if I should put it here, I can't go up because I have to move to an allocated cells, and there are no allocated cells here. So I have to stop here because there is an allocated cell here. Are you getting it now? So I will my loop here. I will also loop here. Are you getting it now? I will also loop here. Now if I should loop here again, coming to this place, I can't go back up because there are no allocated cells here. I can only turn to my left because there is an allocated cells. And if I should turn to my left where there is an allocated cells, I can't move downward because this is not an allocated cell, and I can't move upward. Definitely I'll keep going. Here, this is an allocated cell. You can see definitely my loop will be this. The meaning of closed loop is that where you begin, that's where you have to stop. That is, you start here. Are you getting it? Here, here, then back. You can see the loop. You can see the diagram. This is what we call looping. Definitely look at my loop. That's my loop. Having done all this, the place that I want to, this place, which is my row 3 column 1, I'm going to put a positive sign. Put a positive sign here. Put a negative sign like that. Positive, then negative. That is, I must put positive or negative in every area that I touched. All my corners. Can you see? Can you see? Now, having done that, this place is negative, positive, negative, positive, negative. You can't say positive, negative, positive, negative. No. Positive, negative, positive, negative. Like that. That is, you must have both positive and negative in one column, and same thing. You can see negative, positive, positive, negative. You can see. That's how loop runs. After then, you will now go back. You will now see that, look at these negative figures, the negative value. You will see you have to deduct 1 from this, add 1 to this because this is positive, deduct 1 from this, then add 1 to this. That's what we want to do. Now, here, 1, because the lowest value here is 1. So you deduct 1 from here, add 1 to this, because 1 is the lowest value between this negative. So minus 1 minus 1 will give us 0. 1 minus 3 will give us 2. Sorry, I'm using this. I'm using this. 1 plus 2 will give us 3. Remember, I still have this, but I'm not taking this. Still have 3. Remember, you are going through this. Minus, plus, minus, plus. You are not touching this. Here, 1 minus 2, 1. Then 1 plus 0, 1. So this is the new cell we have now. This is the new cell we have. Having done that, we are now going to start all over from how we are doing shadow cost of allocated cells. Remember that you must always satisfy the condition row plus column minus 1 must give you the number of allocated cells. Row 1, row 2, row 3, column 1, column 2, column 3, column 4. So you see m plus n minus 1 must give you number of allocated cells. So your m is 3, your n is 4 minus 1. That will give you 6. So let's count. 1, 2, 3, 4, 5, 6. Can you see now? So you see satisfy that condition. So the next thing, we are going to recompute our shadow cost of allocated cells the same way we computed it. So shadow cost. So if you did not get the first one, this is another opportunity to get this of allocated cells. So remember, we are using row plus. So remember the formula that we are using as we've used earlier. So row 1, you always row 1 plus column 1 will give you 13. So you always let your row 1 be equals to 0. So 0 plus column 1 will be equals to 13. Hence your column 1 will be equals to 13 minus 0. Column 1 will be equals to 13. The same thing applies to this. Remember, we are using allocated cells. Row 2 plus column 2 will be equals to 14. So row 2, I don't know my row 2. And I don't know my column 2. So definitely I'm going to skip this. Because I don't know row 2, I don't know column 2. You skip. You go to row 2 plus column 3 will be equals to 12. I don't know row 2, I don't know column 3. You have to skip again. Now, let's go to row 3 plus column 1 equals to 18. Row 3 plus column 1 equals to 18. I know my column 1 to be 13 from what I calculated here. So row 3 plus column 1, which is 13. Write your 13 is equals to 18. So row 3 is equals to 18 minus 13. Row 3 is equals to 5. Remember, I now know my row 3. So let's go to row 3 plus column 2. Remember, I only know my row 3, and there's no row 3 from what I want to use here. So row 3 plus column 2 will be equals to plus column 3 rather. Row 3 plus column 3 will be equals to 14. So my row 3 is 5 from what I calculated here. My row 3 is 5. Column 3 I don't know, is equals to 14. Column 3 is equals to 14 minus 5. Then my column 3 is equals to 9. Since I know my column 3, I can now go back to this place now. I can say row 2 plus column 3 is 9. Are you seeing it now? Column 3 is 9. That equals to 12. So row 2 is equals to 12 minus 9. Row 2 is equals to 3. Since I know my row 2, I can now go back here. 3, which is row 2, plus column 2. I don't know my column 2, equals to 14. Column 2 equals to 14 minus 3. Then column 2 is equals to 11. Now, remember, I only stop at row 3, column 3 here. It remains row 3 plus column 4 is equals to 12. Can you row 3? What is my row 3? I have 5. Then my column 4. I don't know my column 4. But everything will give me 12. So column 4 will be equals to 12 minus 5. So column 4 is equals to 7. Hence, we have row 1 to be 0, column 1 to be 13, column 2 to be 11, row 2 to be 3, row 3 to be 5, column 3 to be 9, and column 4 to be 7. Now, having done that, the next thing to do is to check the level of optimality again, whether we can find any positive figures. So let's check the level of optimality. So remember the formula we used earlier: row plus column minus actual cost of unallocated cells. Remember, we will be dealing with unallocated cells. As we've done here, we dealt with unallocated cells. You can see. So here too we'll be dealing with unallocated cells. So the unallocated cells here in this question, we have row 1 based on the new thing that we've done. That is based on this new one, not based on the old one. Based on the, remember, we created a loop before we could figure out this one. So row 1 column 2, row 1 column 3, row 1 column 3, row 1 column 4, row 2 column 1, row 2 column 4, row 3 column 2. So row 1 now, as we said that earlier, row 1 based on the new one we've calculated, not based on the old one. Row 1 is 0. So row 1 is 0 plus column 2. Column 2 is 11 minus row 1 column 2, 11. That will give us 0. Row 1 again plus column 3, 9. Column 3 is 9. Have you seen it? 9 minus row 1 column 3. Row 1 column 3, we have 15. Here we have minus 6. Row 1 again, column 4. Row 1 column 4. Row 1 is 0. Column 4 is 7. Minus row 1 column 4, we have a 20. That's minus 13. Row 2 column 1. Row 2, we have 3 to be row 2. Column 1 to be 13. Minus row 2 column 1, which is 17. That's minus 1. Row 2 column 4, that's 3 plus column 4 is 7. Remember, 7 minus row 2 column 4, here we have 13. That will be minus 3. Then we have row 3 column 2. Row 3 we have 3. Column 2 we have 11. Then row 3 column 2 we have 18. So this is 14. Row 3 sorry, row 3 is 5. Row 3 is 5 plus column 2 is 11 minus row 3 column 2 18. So that will be minus 2. Now if you check this now, there are no positive signs there. There are no positive signs. Definitely we've reached the level of optimality. So we are through with our work. The next thing now is to determine the transportation cost, determine the total cost. In order to determine the total cost, you see that we have row 1. You now pick total cost of allocated cells. So we have our allocated cells. We have row 1 column 1, row 1 column 1. We have row 2 column 2, row 2 column 3, row 2 column 2, row 2 column 3. We have row 3 column 1, row 3 column 3, row 3 column 1, row 3 column 3, and row 3 column 5. So you now multiply 2 times 13, 2 times 13, 3 times 14, 3 times 12, 3 times 12, 1 times 18, then 1 times 14, then 5 times 12. So 2 times 13, we have 26. Yeah, we have 42. Sorry, 2 times 13. Then we have 36, 18, 14, then 60. If you add that together, we have, so this is the final answer. So if you have any question, feel free to ask me, and in the next video I'll be using minimum cost method instead of the northwest corner that I've used earlier as the method of allocation. I'll be using minimum cost method. Stay tuned and subscribe to my channel. Click the subscribe button. Thank you and God bless you. Please subscribe to my YouTube channel, like and share, and recommend this to your friends. Thank you. One love.